Assalamu alaikum warahmatullahi wabarakatuh. Dear students, in this session we are just continuing our discussion from our previous sessions related to multiple linear regression analysis, where we have just covered the concept of hypothesis of overall significance. And there, dear students, you have just learned that if the significance f value is less than 0.05, then we are saying the model is significant overall. But if the p value or the significance f value is greater than 0.05, then we are failing to reject the null hypothesis and simply conclude that the model is not significant for all reasons. But luckily, we have the significance f value less than 0.05. Yes, then it's now logical just to come down and check which variable is indeed significant. So we have three independent variables. In our hypothesis of individual significance, we have three sets of hypothesis students. So our claim for the grants that the grant has a positive effect on the GDP. In the technical way, the beta 1 should be greater than 0. And yes, we found out that beta 1 is just greater than 0. We are happy here. But keep in mind, your students, it's really not enough. You should check whether it's statistically or significantly greater than 0 or not. Okay, then for that you should check the p-value. If the p-value of each coefficient is less than 0.05, it means yes, this value is significantly greater than 0. So merely not greater than 0 is enough. Just check whether it's significantly greater or not. For the significance, we are just checking the p-value response. Okay, so what's the concept here, dear students? Okay, why? If you remember, I have already explained several times the idea of normal distributions. Once again, I'm just repeating here for this concept. Okay, dear students, assume this is the normal distribution, and I'm sorry for my not good drawing. Okay, anyhow. Okay, dear students, look, this is the normal distributions, and this is the area where I'm just rejecting the null hypothesis when it's actually true, simply. Okay, this is the central point, right? So for the grants, what does this p-value mean, dear students? Okay, now when you find out the beta, we found out the beta, assume that it is 5.46, for example. It's indeed not 5.46, it's just 0.000005546, but just assume it's 5.46. Now when you find out the beta, right, then you should standardize this beta. It means you should convert it into its t-statistic, right? So what is the function of t-statistic, dear students? The function of t-statistic is just measuring this value on the graph. How many standard deviations? Converting this value into the number of standard deviations. So you can say this is just 3.428 standard deviations. So if the central value beta, this is the beta in our example, for example, this is beta 1, and the beta 1 is simply, this is 0, right? Okay, now when you convert the beta 1 into its standard unit, which is t-statistic, right, 3.42, then in the t-distribution, just check where this 3.428 value lies. What is its cumulative distribution, probability distribution, dear students? So this is the critical area. So you can say that this 3.428, according to this p-value, the p-value is just telling us that 3.42 standard deviations value is just in this area, which is the area of 0. This area is just less than 0.05. So once we found out that this beta, the standard t-statistic value of the beta 1 is just in this range, so we can claim it's significantly farther. It's way away from this beta is equal to 0. Once it's significantly far away from the 0 and just lying in this area above the confidence interval 95%, then we are rejecting the null hypothesis and we are claiming yes that the beta is significantly greater than 0, dear students. That's the logic behind. So keep in mind, what is the t-statistic? The t-statistic is just converting the coefficient value into the standard units, and then the standard units is just compared on this graph. And just checked the t-distribution, you should just check that the 3.42 is lying where. If it is just lying below the significance level 0.05, it means it's significantly greater than 0, and that's the point we just got it. Okay. Okay, and the same concept is applied to FDA in agriculture, but keep in mind, the standard units are the t-statistic value for the first coefficient is 3.42. This logical is too far away here, but this 3.14 is also just farther away. But this 0.81 standard deviation is just closer to 0. So that's why, dear students, we can say in this situation, the coefficient of FDA is not significantly different from zero. It's not far, it's just closer to zero. That's why we are failing to reject the null hypothesis. In these situations, we cannot reject the null hypothesis, and simply we fail to reject the null hypothesis, dear students. Hopefully the concept is clear. Okay, now I'm just explaining what is meant by the standard error. This is just remaining, dear students. Okay, very much simple, dear students. What is standard error? We have the standard error. This is the standard error, right, for the coefficient, and this is the standard error for the coefficient of FDA, and this is the standard error for agriculture. Okay, dear students, if you just take many samples and compute the beta 1 or the coefficients multiple times and just create the sampling distributions of the coefficients, right, and just compute the standard deviations of all coefficients, that is just simply giving me the standard error. Once again, dear student, for example, I just giving you the concept here. Okay, if you just compute the beta 1 one time, taking the sample in the beta 1, for example, that is 5.46, and the second time you just take the sample, the beta 1, that is just 4.56, for example. In the third time, you're just taking the sample from population and computing the beta 1, right? Because each time the sample can be different, and just computing the beta 1 can be, for example, that is 5. And the next time the beta 1, for example, that is just 3.6, right? So when you have the sampling distributions of beta 1, I'm just computing the standard deviation for what is the standard deviation, for example. What is the, assume I'm just computing the standard deviation of this. So you can say the standard deviations mean the beta 1 is just fluctuated by the amount of 0.79. So you can say each beta 1 here, so this is a standard error. So you can say the standard error is the standard deviations of the sampling distribution of the beta 1. So you can say each coefficients we have is just fluctuated by the amount of 1.593. So this is the error. This is a possible error in each coefficients. So the greater this error is, the less reliable and less relied upon on this value is. So you can say this value is not much accurate and much representative, not free from bias once the standard error is really great and just the amount is bigger, right? So once again, dear student, the standard error is just telling us about the fluctuation, the average fluctuation around the coefficients we have. So the standard error is somehow close here, and here is also close here. Okay, hopefully the idea of the standard error is clear. So if you remember, we also had the standard deviations above, and that is the standard error of residual, right? How much the residual by average is just deviated from the regression line, or what is the average distance of the regression line from the residual, that is the standard error. And here, dear student, what is the average deviation of the coefficients from the central value? You can say this coefficient just can be fluctuated by this amount, higher or down, right? Okay, hopefully this idea is clear. Okay, and what is test statistic, dear students? This is what I've already explained many times with more example. Test statistic, dear student, that is just converting this value into the standard unit of standard deviation, right? And just for the comparison here. Okay, dear student, for the regression analysis, the test statistic value is very simple. In some different way it's calculated. So you can say the test statistic value here, that is just computed for each coefficient. The test statistic is just equal to, just take that coefficient, for example, for the first, which is grant, the beta 1 should be divided by the standard error, of what? This is standard error of beta 1, simply register. Okay, once again, if you just find out here in Excel what is this statistic value, this coefficient, this is a coefficient. The coefficient should be divided by the standard error, that is just giving the test statistic value, students. Okay, hopefully the idea of the test statistic is also clear. Okay, finally, students, we have the confidence interval here. Okay, we have already explained the idea of confidence interval. In the confidence interval, we have the lower value and the upper value. So you can say the confidence interval for the coefficients of the grant, this is for the coefficient of grant. So this is the lower value distance, and this is the upper value. Simply, you can say we are 95%. Why? Because this confidence interval just built around the confidence, around the the significance level of 0.05. So the confidence interval is based on 95%. So you can say we are 95% sure that the true coefficient is just in between this area. Okay, this is the coefficient 5.46. This is estimated one. So we can say we are 95% sure that the true coefficient that is just between this area. Okay, now I'm just asking you a question, dear students. We are just trying to find out whether the beta, right, the coefficient is greater than 0 or not. Once you are 95% sure that the true coefficient is between the 2.08 and 8.8, which is both of them are greater than 0, this is another criteria, so you can just claim that yes, the alternative hypothesis, we have got sufficient evidence. And here we can reject the null hypothesis. Why? Because the 0 does not lie in this range. Once you are 95% sure that the true coefficient is in this range and both of these values they are greater than 0, it means the 0 indeed is not here, and this is a range where we are 95% sure. So that's why from here you can also reject the null hypothesis once the 0 does not lie in this range. Similarly, for this look here, so we are 95% sure that the true coefficient, right, which is 5.8 here, but we said the true coefficient of population is just in between this interval, and where the 0 does not lie here, so and we are 95% sure for this, so we are rejecting null hypothesis. But here, dear students, we have negative and positive. It means the 0 is in between, so that's why the data are the evidence that's too less here. Why? Because 0 is in between. So once the 0 is in the interval, we cannot reject the null hypothesis. Hopefully the idea is clear. Now finally, dear students, what is the interpretation of these coefficients? Okay, dear students, I'm just interpreting one value, right? Okay, for example, for the grants, which is beta 1, the beta 1, dear students, that is for the grant, and the value of the grant, this is the value, and the actual value here, dear students, is 0. Right, this is E-0. It means after the decimal points you should just put 7 0 1 2 3 4 5 7, and then you should start from the 5 6 4. Right, this is, you should learn this, students. Okay, this is the beta 1. This is the coefficient of the grant. So what is the interpretation of this, dear student? I'm just interpreting this one value. You can say, dear student, the interpretation is very much simple. You can say for every $1 increase, right, increase in grants, the GDP per capita increases by approximately, you can say 0. Right, 1 2 3 4 5 6, right, and then 5 6 4, right, dollars, assuming FDA and agriculture stay constant, right? Okay, dear students, once again, we say for every dollar increase in grants, if the grant increase a unit $1, then the GDP per capita students increase approximately by 0.000564 dollar, but assuming FDA in agriculture stay constant. Okay, this is something you should learn about the multiple linear regression model students. When you are interpreting, so each coefficient is just contributing partially. So we can say this is the partial effect of the grant and the partial effect of FDA and the partial of agriculture. So a unit increase, for example, in agriculture is just leading to 0.000058645 units increase, a dollar increase in GDP per capita, assuming the FDA in grants constant. And for FDA, you can say, okay, but one point, this is just a forgot. Okay, for every dollar increase in grants, the GDP per capita increases, right, by approximately, right, 0.00, but keep in mind, this increase is statistical, significant, but this increase, the interpretation here is not significant. So here you can say a unit increase, right, in FDA is just leading to 0.000018932 dollar increase, right, in the GDP, but this increase is insignificant. It means there is no meaning for under the 0.05 significance level. We are not accepting this result, or you can say there is no significant relationship. Only these two variables have significant impact on the GDP per capita response. Okay, hopefully the idea in the concept of the multiple regression analysis is clear, dear students. Okay, the only points which is remaining, the degree of freedom, inshallah I'll make one separate value just giving me the concept of degree of freedom, but simply the total observations we have, that's 20, right? But for the degree of freedom, simply you can say how many coefficients or how many sample statistic they are just used in the data. In each sample statistic, like the mean or the coefficient is just using 1 degree of freedom. So that's why the regression out of the total is using 3 degree of freedoms, and 1 degree of freedom is just used by the average value. So that's why we have the total 19, right? And 3 degree of freedom is used by regression response. Okay, inshallah I'll give you the concept of degree of freedom. And very much simply, the degree of freedom means that if you are just using one sample statistic mean, it's mean 1 degree of freedom is used by the sample statistic, right? And you have only 9 choices out of 10, only 9 choices. Why? Because one is just fixed and used by the sample statistic, that is just the x bar, right? But in case of the coefficients or the regression analysis, you can say 3 more degree of freedom than they are just used by regression analysis. So finally you have 3 less choices are just selection, right? And your degree of freedom, inshallah I'll just give you the concept of degree of freedom in another video. Assalamu alaikum wa rahmatullahi wa barakatuh.